Good morning. Welcome to today's webinar. We're going to talk about virtual design and constructions with Tilt Wall Design to Build. We have the presence of Matt Sweeney, a licensed structural engineer and the digital design manager with PES Structural Engineers, and Dr. Will Iker, PE, PhD, Director of Research and Education at Bay Forum Global. Dr. Iker will be moderating today.
Thank you very much, Luisa. It's a lot of fun to have Matt here with us today, and I'm really looking forward to what he has to cover. And for those who are joining, I want to remind you we'll talk at the end about next week's webinar as well as the following one. We have the LOD specification from BIM Forum Global that's been launched last month for public review, and we're closing out and gathering all the comments. And so next week's webinar will go over the new LOD specification, and we have guest speaker Brian Pravda, AIA, who's an architect and also really a pioneer in moving forward digital design to construction. But with that, I've gotten the pleasure of getting to know Matt through working on the Structural Engineering Institute's Digital Design Committee, and I found him to always be a saged expert in both structural engineering as well as technology. And it's a real honor to get to invite Matt to us. I've asked Matt to kind of give some highlights. He's coming to us from the Asheville area of North Carolina, in that region. And I know other hobbies of Matt that he likes is does a lot of mountain biking. I think you're saying maybe 6 times a week you're hitting the trails, 75 to 100 miles a week of mountain biking, and which is another great achievement in and of itself. I'm speaking to you today from Chicago. So we're broadcasting remote from my end and from the AGC's IT forum. And so it's wonderful to see all the technology come together and move there. But with Matt, I'd like to go ahead and hand it over to you, and you could go ahead and start presenting.
Right.
We're going to be talking about tilt wall today and taking design to construction. Towards the end, we may have a few questions on really how we achieved all this from that perspective. And with that, Matt, the show is yours.
All right. Just to make sure you do have my screen there, right?
Looking good.
All right. So thank you, Will. So I'm going to just go ahead and jump right into this.
Certainly.
First off, just kind of a quick some highlights here. That this is it's a case study discussion. We're going to get into some of the tools and processes that we had to rethink or create to kind of accomplish the goals of creating shop drawings from our design model. So we are going to get into some details around process and kind of a little bit in some weeds. Some I try to stay out of them a little bit here. I did want to just kind of mention that, this is coming from a smaller, purely structural consulting firm. We are leveraging design models to create some shop drawing level documents for the fields, for the construction teams used in the field. And, this is something that really evolved from being a manual process and an idea up to relatively automated at this point. So we're going to kind of discuss why, how, steps, challenges, and the evolution this has taken for us. It's been an exciting topic for me to talk about. It gets into downstream usage of the models, fun tools, process improvement. 3 things I'm honestly really enjoy. So if that isn't what you came for, sorry, but that's what we're going through today. All right. So a quick introduction to who I am. I've been in the AEC industry about 20 years now, 15 with PES in 2 different stints, 7 the first time, 8 this time. It's a little picture of me back in 2005, a little bit younger there. Started as traditional structural engineer, went through all the typical process into project management, the licensed engineer. Now I'm kind of reinvented as the overall office technology guy, dabble with some tool creation. But, the BIM and technology related direction kind of goes through me. I also work with our IT group on our cybersecurity, CRM tools, all of it And like Will mentioned, I'm a big outdoor adventure family guy there. So PES, we are about 55 people strong. Consulting, structural engineering, headquartered in the Southeast. We've been around about 35 years. We have 2 offices and some remote folks. Second group's up in Hartford, Connecticut. We work on all kinds of different projects, a lot of warehouse or light industrial, but everything up to and including this larger residential tower on the right. As a company, we really like to focus on our culture, not just having fun, though we do like that part, but working hard, winning as a team, driving for improvement and owning it. It's also, I think, worth mentioning, we don't have many dedicated BIM staff. Our engineers do a lot of their own work, their own Revit work. We do have a few that get into some things in more detail, but most of it's been engineers. We've been a relatively forward-thinking company. We started with BIM back in 2006. And looked into and started bringing in automation tools in around 2015 or so.
And one thing, Matt, I think some of it, there may be about a second or 2 lag on the slide change.
Okay.
So I'll let you know when it changes, if it's a little delayed, but we're looking at a tilt wall panel going up in the background.
So I hope most everyone in this group is familiar with tilt-up construction, but if not, we'll do a very quick, oversimplified review. It's similar to, I'd say, on-site precast. We've got a casting bed or slab poured. Wall panels are laid out with everything that needs to go in them. Concrete's poured, cured. Big crane comes in, and like you can see on the picture here, lifts it or tilts it into place. It's braced until the roof comes in. It's a very common building system for light industrial, warehouse, distribution center, stuff that in the past couple of years has been going largely pretty well and almost hard to get away from at times. It's also something that's commonly self-performed by a lot of contractors. So they're looking for some detailed information at times. So in the tilt-up construction, one of the main submittals that we need early on is the panel book or panel placement drawing. It's a shop drawing document used by the contractor to physically lay out the formwork and embeds and anything that goes into the panel for the most part, including size and shape, size and locations of reveals, depressions, openings, embed types and their locations specific on that panel. Basically anything you would need to physically lay this thing out, short of rebar and lifting information. Those 2 pieces tend to come from a separate specialty contractor and are typically in their own packages or documents. So, why would we get into this? The first thing is honestly, it increases our role or scope in the project, which is always something we're sort of looking to do as long as we can get compensated for that. But second, it minimizes or eliminates the interpretation of our drawings in an area that we're very suited to cover. Since we created them, we can make sure they're detailed as they're expected. Interpretation can be tricky, as you see here. Also, getting into schedule timing, we can start development a lot earlier on this stuff because we are ready and familiar with, how the schedule is going, what areas can be worked on, what areas should be held, those types of things. And it also helps us forge stronger relationships with some of our clients. We're now providing more service for the project and getting more interaction with them. So the why seemed to make sense, but how did we actually get going in this or, stick our foot into this door? To be honest, it started with a strong relationship with one of our developers. We had some projects where there were a lot of issues around embed placement and layout. And they sort of looked to us to say, hey guys, what can we do to help? How can we make this better? So like I said, we're always kind of looking to increase our scope. We've been fairly entrepreneurial as a company over the years. So we had some discussions and decided that we would look at trying to create some of these things on our own. We didn't go into this with blinders thinking that we were just going to hit go from our models. We understood we make design models. They are not quite the level of development you would need for a shop drawing. So we knew we had some challenges. We didn't have reveals or some of the panel features, some of the joints, those things might have been missing, but we may have overestimated a little bit how well the BIM process was actually working at the time. Architects maybe not fully modeling all of their information. How was communication going to work? And just the level of coordination you need to get into this detail was just a little bit more and different than design work. But we had some thoughts.
And one question I was going to ask in this, Matt, as I'm looking at it, this process, may have evolved a little over the years from when we had file-based asynchronous workflows versus now cloud-based workflows. In these examples you're going to be talking about today, were you using a cloud-based solution where you're synchronizing from your modeling environment with other stakeholders, or were you basically local file that you would upload periodically for coordination?
Both, but most of these would be on the cloud-based solution, honestly. So we always had the architectural models up to date. We had the structural model up to date. And I'll touch on how that's different from the panel drawing model at times, because we'll get to that in a minute. But yeah, mostly a cloud-based model where we kind of have everything linked in and shared along the way. So some of the things that we originally thought, and this is kind of where we started, is that we thought maybe we would save ourselves some headache by minimizing sheet count. I'll touch on that a little bit. We knew we were really going to have to detail processes out. This is not our bread and butter work, something we do all the time. We were going to have pretty detailed processes. We were going to look at, make sure we leverage some of the construction tools in our platform that we don't normally get into. We had a pretty robust intern program at the time. We knew there was some repetitive work, so we could leverage that a little bit. And then automation was something that from the beginning we knew we needed to get into and bring into this process. But when we started this in 2016, we were just learning some of the automation tools. We had some very basic coding knowledge, but we felt pretty good about it. So the first attempt didn't quite go as planned. It wasn't really a lot of fun. It was complex. Some of the places that we thought were going to be easy were not. There's a lot of view making, a lot of sheet making, dimensioning. Just by the time we got through it, we realized we needed to make a change, and then had to go back and redo a lot of things. We didn't do so well from a profitability standpoint on that first one, and we certainly weren't going to get a lot of volunteers from the office to work on this process if we didn't make some adjustments. So we started looking at refining this, and we tried to be methodical about this. We broke down the steps, made some tables with solutions, put it into 2 big buckets, and then asked ourselves some questions like, what things were the most achievable? Where would we save the most time? What was the most egregious to the actual end users? What steps had application in our typical workflows and typical processes? Not all these answers aligned with each other and made it obvious, but they gave us a good framework to get moving with. So our initial, our lowest hanging fruit honestly seemed to be we absolutely had to improve the LOD or level of development. Shop drawings, like I said, are quite a bit more. Our design models are closer to LOD of 200, where shop drawing is going to be, in the 350 range. So we needed to get some detail into our model. The automation of getting embed plates seemed like it was a good place to start. We have walls, we have intersecting joists. Most of your primary embeds are going to happen at some sort of intersection of a wall and another member, be it a joist or a joist girder or a roof of some sort. So we turned to Dynamo, intersected the face of the wall with the joist, got ourselves a point and dropped in a family at that location. For the most part, it was pretty straightforward. It got a little interesting because when you go to place hosted families into walls, your coding gets a little bit different, and maybe above our pay grade and understanding at the time. So we actually turned to non-hosted families because it allowed us to continue to move forward with this. We just at that point had to figure out how to get the orientation to match the wall, which was relatively straightforward. So we made pretty big steps there. We got into the deck edge, and this is an area where we didn't quite always realize that the architects didn't model the roofs as accurately as anticipated. We didn't necessarily want to model the roofs in our models. So we went through and kind of kept a simpler approach, and our joist girders had to be modeled correctly. So we took and added some model element aids from top of joist girder to top of joist girder and kind of extrapolated that out and used that as our guide for our deck edges. And it turned out to work really well and cleanly and consistently for us. So with that, we had pretty big step here in getting these into the model. And you can see here, didn't require much user input, but what you notice is that I did speed this video up quite a bit. This is just 2 panels, and it takes a little bit over a minute to get all those in there. So if you stretch that out, this one was not quick. It was functional, but it wasn't quick. But again, it got us a step forward. So we went from there into panel joints, and these are often overlooked. Design models don't show some of the construction tolerance, between the gaps between the panels or the gap at the bottom for the grout bed. There's a couple ways you can consider doing this. You could physically shorten the walls, but that had implications on how the footings worked, and we wanted to be able to go from center line to center line, so that wasn't quite what we wanted to do. But we went the approach of just putting in full depth reveals at each end of the wall to create that gap. We assumed and thought this was going to be really straightforward, and we felt really good about our automation abilities. We were wrong. Dynamo didn't quite play as nicely as we wanted it to. Just would only place one of them. But what we did learn is that we found some macros that access the API a little bit differently and allowed us to get most of them modeled relatively well and relatively close to what we needed. We did need a few manual changes here and there, but it was well over that 80% rule. So again, a big step forward in getting this done without all the manual work. Maybe not perfect, but again, we're trying to steps forward and steps in the process.
And Matt, I had one question in this area. We've seen a lot of examples in precast, but there you have a much more controlled manufacturing environment when you get to the casting beds. With tilt wall, you're on site. I guess it is assumed we've got a lot of manual layout in the field. And on most of your examples, are they basically working off paper in the field on these embed layouts when they're setting them in the formwork?
Yes, they
Okay.
are almost always working off of paper, and I'll mention that in the couple slides here. But they get to where they want one piece of paper for each panel, and they can
Right.
basically set that out at the base of the panel, and then everyone can reference that. And that's how they prefer it at the moment. So it's interesting how that works, though.
Definitely.
Moving into like the next piece of the model here, though, is the reveals. You know, as structural engineers, we don't get into this that often. We don't model these. You know, once we know the depth, we can design our panels around that depth, and we don't have to pay. We look at them to make sure nothing crazy is going on, but we don't have to deal with the specifics of them. For the shop drawings, they need to be accurate. They need to be dimension tagged and all there. So, you know, we initially just went with the idea that we have the architectural link. We can turn that on, dimension them, and go from there. That makes a assumption that the architect has modeled all the way around the building accurately, which early on was not the case. A lot of times they would model one corner or one wall, one elevation really well for their drawings, and then they might not take it all the way around the building as consistently. You also relied on their families for tagging and you know, what dimensions were available, what dimension planes. Any adjustments they made in their model could ripple through your drawings and take out a lot of your dimensions the day before you wanted to submit. So it only took us once or twice to realize this was not the way forward. We couldn't just copy them in early on because we couldn't have them in our design drawings, and also early on they're not usually correct. They're placeholders and they'll adjust later. We looked at trying to copy them in later, but it had some negative effects and didn't quite work. We did realize at this point, this is where the panel model had to separate from the design model a little bit, though, because we needed to add a lot of detail that really couldn't be in the design model at that point. So we would leverage the design model all the way up to here, and then kind of make a fork off of it to continue adding more detail. On the way, we realized and found out that wall orientation had a large impact on any sort of automation you wanted to do. And most of our team is pretty good about modeling very consistently, but sometimes you're modeling or copying from architectural walls, or you're copying walls around, and this just gets missed. So we made a few different graphs to help us get everything in line. And we really stuck to the keep it simple approach with this one. We actually made 4 different graphs so that it was very approachable for anybody in the company to use. You didn't have to wonder what was happening or do anything weird. You could just pick the walls you wanted to face one direction. We put that into Dynamo Player, so it was very simple for everyone to use. As I was going through and trying to find Dynamo Player images, really all I could come up with was the Houston Dynamo. So I wanted to give them a quick shout out for winning the Google search. They have got it on lockdown. So once you get the model where you want, you know, you think you've made good progress, you get into the views and the sheets and the documentation, and that's where the fun part really begins. And this is really where your automation can save the day. The first one we did was largely manual, and when I say largely manual, we really had almost no automation. So we did most of this by hand. And like I said, we tried this idea that less sheets was going to be less work. That's incorrect. Less sheets actually becomes more work because you got to try and squeeze them into these little blocks. And it's not really what they want in the field anyway. They really want one sheet per panel because it just makes it cleaner for them. They can basically staple it to the formwork almost, and then everyone has that sheet to reference. They don't want this grouping of panels. But we got into the view creation. Each panel has two different views associated with it, a reveal view and an embed view to keep your dimensions somewhat clean. The first time this was creating an elevation, copying it around the building, using an add-in to duplicate that, then renaming and view templates. It was very manual, very haphazard, to be honest. Nothing was identical. Trying to automate anything really became a challenge because it was so bespoke. And then you had to get into creating sheets. So at the end of the day, this got really, really cumbersome. Some of these buildings have over 190 panels. So we really had to get into doing something with this. We transitioned this into more Dynamo to create sheets, create views for each panel. That created each one of our views. It also made sure that they were created with intentionality. They were consistent. They all had the same gap on the end of each wall. They all had the same view depth. Everything was the same, which meant we could easily make edits along the way. We knew what we were dealing with. Cropping issues, we had filters created from that same setup that filtered out the panels next to it. There were still some challenges, but this was pretty big for us. The bigger task, though, was making the sheets. We actually turned to a couple pretty basic add-ins for this, using ArcSmarter to make different sheets from an Excel sheet that basically puts all of the views on the sheet, and then we could turn back to it to align the views. So now we had all of our sheets and views created with a few different steps. The tools and steps are adding up, but it's a scalable process at this point, as opposed to just how much clicking can you do. Now we're starting to get into this scalable process. We still needed to add our schedules to the sheets and create the schedules. So we stuck with our keeping it simple. We went and made a few more different graphs to put those together, put them on sheets, and keeping things as their own step in their own graph made them easy to troubleshoot. It made it easier to teach people what was going on, because you really did have a step-by-step process. And again, these steps are adding up, but it is kind of a scalable process. And with that engaged team, it was almost starting to become fun, and there were reasons and discussions like it was almost like a game to try and find out what next step we could do to make it cleaner and easier for us. We were making really good progress with this, but then we got into dimensioning and tagging, and there's a lot of dimensions and tags. They really have to be accurate. If you do this manually, you bring in some opportunity for human error with picking the wrong reference plane or just skipping and missing things. So we really knew and wanted to make some automation happen. We were starting to see more of this come in. Things were starting to pick up, and we needed to make some progress quickly. We'd been in this for a few years now. Developing those tools on our own became a challenge. With Revit changes, API changes, which means you had to update the Dynamo tools, the macros. We're trying to keep up with that on our own was tough. We came across a tool from AGA CAD that looked like there were some promises actually geared towards precast. It was a little different than what we were doing. As Will mentioned earlier, it's a lot more controlled, but the end goal was actually quite similar. We did a number of demonstrations and trials and testing, and found that we could use it as a platform to get to where we wanted to go. And definitely not a commercial here. This is not an easy button, but it was a platform that gave us the ability to kind of leverage what we had done already and take it further. So even though like our main focus with this tool was dimensioning, we realized there were a lot of opportunities to improve our modeling. So we actually jumped on that first and streamlined how we were placing our embeds and our panel joints and gaps and everything along those lines, even the reveals. There were tools for rule-based placement of any sort of face-based families. So we had a lot of options to make this go quicker. Someone else would maintain the code for the future. So, we were really able to jump in and just real quickly, you can see in this case, I just go to choose this and get started. It brings up a dialog, which what I learned was that it likes to hide on you sometimes. So you have to go find it, which is part of the quirkiness. You choose a profile and hit insert. This video is real time. It wasn't actually sped up at all. And that happens that quickly. So what used to take 45 minutes to do now happened in a couple seconds. So it was probably the difference between an amateur coder and a professional, but became a big deal.
As we look at that, is that using essentially in this modeling tool a split tool, or is it rebuilding distinct separate wall pieces?
Wall pieces are already split up. We do that early on. But we actually do use this tool to split them most of the time. And we can put in parameters to split them. But we have always gone with the approach of modeling each panel as its own wall. It has helped our workflows tremendously over the years.
How much are you finding on those jobs that evolves, say, after 50% construction documents, or are you finding with most of the architects you work with, they get it right early and that part's not moving around very much?
I'd say 90% of the panels don't move much, and there's a 10% at maybe an office corner that might adjust some along the way. But most of the building is pretty set very early on.
And then in precast, you're trying to always keep every panel the same.
Yeah.
But are y'all automating? It could be, it can be helpful until it will as well. Are y'all automating the nesting and grouping of panels to get as many duplicates as possible, or are your designs a little more organic?
Yes and no. We do some nesting and trying to minimize the amount of types. And we will lean on some automation tools to help us see that. But we also have a number of clients that we know are going to end up much more organic, as you so elegantly put that. Good discussion there. So the biggest game changer here was really getting into the documentation piece of this, and that's kind of what led us down this road, was getting all of these pieces of view creation, sheet layout, dimensioning and tagging, kind of bringing it all into one large template in one tool, albeit it's a very complex tool with a lot of different pieces. And at the end of the day, it really is leveraging some of the built-in pieces to Revit, but it really makes everything a lot more approachable. We had investigated a lot of the out-of-the-box tools and didn't have a lot of success getting them to where we wanted them. just with too much user input, and this really kind of gave us that platform to put it all together. So we have the ability now to put in templates for our view creation and the sheet creation, so everything gets to where it wants to be. But ultimately, the dimensioning is really and tagging are the key parts to this. And there's a lot of tools around getting these set up the way you want. The biggest key is that now you've defined what family you want to and what reference planes in the family you want to tag, and you get that exactly correct every single time. And it works really cleanly at that point. And just to kind of demonstrate that quickly here, if you select a few different panels here, and these all have everything that they need in them. This is real similar to, just watch me struggle to pick on that panel there, but really similar to what we saw with the putting in the embeds. You pick on that, and you can actually go, look at your templates if you want, which views you're creating, which schedules you want to create.
And so as we look at this, I see you got the panel selected, and then you pull this dialog up, and it gives you a lot of granularity. And this is this the third-party plugin you're using?
Correct.
Okay.
And then we get those sheets, and now I've made sheets, and you can see all my dimensions are in here. At the scale we work at for these, there is still some cleanup. This is getting better with every update, but we will go in and clean a lot of this up so that it's a lot more legible. But you can see that it becomes a very repeatable thing, and this is where it really kind of change things up at that point.
And so we're getting the front and the back, and these are essentially, I guess, an ANSI B 11 by 17 sheet.
Correct.
Okay.
Front, back, 11 by 17. Every sheet, every wall is on its own sheet. As list of which embeds are which, exactly where they are from the edge of the panel. So, and they're both from the outside or inside out, because they're going to form these face down. So they're both from that inside out, so that you are kind of, when you pick up that sheet in the field, you're looking and stand at the base of the panel, you're looking out over
the formwork.
What it says, your formwork.
So
and
one thing that comes to mind is nesting and quantification of your embeds. I see you've got your marks and your bill of materials in the upper right. Were you able to automate a lot of your embeds for quantity takeoff?
At this point, you can actually double check this against your steel submittals to get your exact number of embeds, because you've got all of those quantified here. So you take those numbers and match them up against your steel submittal, which is nice to verify and double check.
And I appreciate you taking some of my questions here as we go. And for the audience, please feel free to submit questions through the interface here. One thing that comes up, Matt, is you've got your bar joists, and those are going to be from your joist manufacturer, and they have a steel detailer. And then you may very well, on the posing orthogonal directions, have some structural steel beams that connect in. If you're not using a trussed girder type system, you might have some traditional structural steel for columns and maybe a few girders. And that's another steel detailer working under the structural steel fabricator. When we're looking at those, I guess perhaps you might have canopies outside the building that could be a miscellaneous metals. You might be yet a third detailer working under a fabricator. So even when we say steel on one job, you may have 3 steel detailers from 3 separate firms. In theory, one could be, I'm not plugging any of it, but one could be in Tekla, one could be in SDS2, and another could be Advanced Steel. each of those have to have an embed to do their part. Has anyone ever really asked you for, a DXF or a 3D CAD export of just your embeds as a reference? Or are any of the GCs you're working with, looking at that level of coordination?
Unfortunately, not yet.
Okay.
I would like to see it happen, and I'm looking forward to the day that we get to have those levels of back and forth. Because in turn, I would prefer to have their IFCs or DXFs or whatever format to plug back into our model for coordination and verification.
I'm sure your firm is similar. We've got these remedial typical details for when an embed's in the wrong place and you post install a plate you're bolting on, after the fact. And it's really exciting to see what you're doing, because you're potentially giving, the construction manager the chance where we don't have to use that remedial missed the embed detail.
And fortunately, in the ones of these that we have completed to this point, we've had very few misses,
Sure.
Which leads me into progress here. How's it going with this? To date, we've done 16. Actually, since I finished this, we've done another one. So 17 of these projects that have been up and down the East Coast with a few different contractors and project teams, both internally and externally. Minor differences. And one of the things that we really try to make sure that we do before the set even leaves our office for the first time is do a quick cursory review by the design team to try and just catch things before they even leave. Because the way we approach this service in-house is that we have a separate team do the panel embeds from the design team, because we want to keep that separation so they are familiar with how our company works and how we detail and things like that, but they are not the same team who did the design. And we think that has benefit to the overall project. But we do try and make sure that the design team gets to look through it real quickly. They're still going to do their review, but they can look through it to make sure that it's generally in line with what they would expect to see before it even goes to the contractor for initial review and approval. So when you look at this graph, the bars are profitability, the line is hours spent on each project. And for the most part, this makes pretty good sense. The hours spent continue to kind of go down for the most part, and the profitability largely stays up, and goes up and stays there. 2020 is when we really moved into that new plugin, and that first one was a pretty big learning curve. Since then, we've largely been getting in the right direction. We do have continuous R&D, which is why it's not always trending in the same direction, and some retraining and things like that. But we've largely been moving in the right direction with this.
Because this is a very popular structural vocabulary, if you will, for buildings, data centers, distribution centers, big box retailers in a lot of markets. And without going into a lot of details, there's a certain conventional wisdom of how many dollars there are per panel. And it's really, as far as just 2D panel book creation, is almost a commodity. But the real differentiation here is you've created a framework that can facilitate some very detailed coordination between something that's typically notorious for the general contractor to miss the coordination of. And so without getting into dollar amounts, are y'all approaching being cost competitive in your markets with what 2D panel book? I mean, these are sometimes just a single operator working with 2D CAD who's been doing it for 20 years, and they can, sit at their house and bang out a lot of panel books sheets really quickly. Are y'all approaching being cost competitive? Because what you're doing, there's no comparison to the level of coordination you're providing, but how is the market receiving this service, and is it specialty clients, or are you breaking out into more competitive market conditions, and then are you only doing it for jobs you were structural engineer of?
Those are really good questions. From the cost competitive standpoint, at the moment, I don't have the answer to that.
Okay.
Following up on that, though, we are not limiting this to jobs that we have, that we were the structural engineer to date. That's been most of them. We are branching out on that, though.
Mm-hmm.
And you're right. The bigger value here is more of the coordination part of it, more so than just getting the documents done.
Sure. And
so
there's a number of precasters are starting to move to laser layout. And that has been, so essentially taking a model like you have and using laser projection, where it will basically, they have to look at, daily calibration, but it will project outlines on the casting bed where each embed goes. The text it's as if you could take the 2D CAD and you just
lay it out.
And so one of the challenges for tilt wall in that regard is most of the precaster fabricators I've toured, and I spent about 2 years with Precast Concrete Institute doing research with them, touring the country, visiting different precast facilities. The ones that were able to do that had indoor casting beds, and it's harder in bright daylight at that time. But I've also seen a lot of advancements with robotic inkjet printers now that'll go over the slab, and they're using, I've predominantly seen the applications for wall layout, but essentially have you visited with, or is anyone talking about how to use digital projection for tilt wall panels?
I have not visited with anybody, but it has certainly been one of the things that's been on our minds with doing this is, we will have or be much further along in having that capability, or being able to provide something along those lines than say a 2D CAD. But no, I've not actually seen that in place yet.
Tell us a little bit about your project and the tools, progress and the tools you've got listed here.
So, this is something we continue to streamline. We are cleaning up families. We pared down our tool list. We keep looking at ways to make it cleaner. Honestly, the wall panel tools and the tools are saving us time on our typical projects, as well as, these panel book projects, and trying to make sure that we move this information into kind of what we do for just typical model creation. And like we just mentioned, we do actually plan on chasing this work in more areas. We think it helps us grow on our understanding of the building in general, but also get into projects a little bit more. And the ultimate goal with this is spending more time on getting the projects better, coordinated, the data right, as opposed to creating these drawings, which leads right into those questions you were just asking about layout and robotic layout and both laser layout is making sure that the data is right and coordinated, and then the drawings are sort of a side piece.
Excellent. Some of the things I'm thinking about, you brought up, Matt, is you'd mentioned you'd like to see the general contractors be a little more proactive in the coordination and bringing in other trades. And you can segue to that next slide, because this is a great transition to that. Next week's webinar will be on level of development, and Matt will go to that slide 27 here in just a moment. So it's going to be talking about the LOD specification, and it's going to be next Thursday at 11 a.m. Eastern, and you can sign up for that at bimform.global events. One of the things we're going to be talking in there, Matt had mentioned in this webinar, a desire to see the construction side leverage some of the benefits of this process. And one of the things we're going to be talking about in next week's webinar is, one, intimately understanding the LOD specifications. And what I showed in this image is a precast example. It's not a tilt wall, but it's very similar. And one of the areas that's being added for this new LOD specification is the tilt wall section. And that's building off the American Concrete Institute's 2021 LOD for concrete guide. They produced a tech note for guidance for the concrete industry on LOD of concrete. And the BIMFORM Global's LOD specification is the first to really address that and adopt that guidance from the American Concrete Institute. In that presentation next week, we're going to also talk about concepts and ideas for including in the general notes for both architects, structural engineers, and mechanical engineers. And we'll be talking about where in the project specifications that designers can start to include requirements for quality and testing. These are already known sections of buildings in their specifications. If you have concrete, there are requirements for quality and testing. If you have reinforcing in that concrete, there are requirements for quality and testing. And sometimes those are requirements that are on the material providers. Sometimes those are quality control procedure requirements that are on the general contractor or their trade partners. Additionally, you're going to have the whole entire shop drawing process is a quality control mechanism that communicates back to the designer that certain steps have been achieved. And so if we think about all of these things in the BIM world, it's completely appropriate for designers to now start to include, as part of the quality assurance, quality control processes that have been in specifications for years and decades, BIM requirements. And we're going to talk about defining a project origin in the structural drawings for a local coordinate system. We're going to talk about LOD requirements for the trade partners. We're going to talk about initial trade models being available to the design team. Some design teams may want to do model-based fabrication and shop model review. Others may want to purely rely on a more traditional workflow. However, they could preemptively see in a federated 3D model that the trade partners have, one, acknowledged the coordination work that had started in design, and two, leveraged that so that when the structural engineer receives the shop drawings, the reviews are really just a confirmation that they were produced from the models that had been coordinated. So there are requirements that are not unreasonable or onerous for general contractors, even on small to mid-size projects. We're going to talk about how designers can proactively begin to provide guidance. So if you're in a project where it is a design bid build, you can simply reference the construction documents, and that BIM coordination is really just part of a quality control, quality assurance process. Matt, have y'all started adding sections in your general notes and specifications that have BIM requirements for the construction team?
Have not at this point. It has been discussion and something we are actively looking at and considering. So
that'll be good. One of the things we're going to do next week is present sample LOD tables that, if any structural engineer who's producing a design under the International Building Code will frequently have a special inspection sheet per the requirements of the International Building Code. And as you look at those, it's completely appropriate, in my perspective, for there to be an accompanying VDC quality assurance sheet and show an LOD table and show what each trade is expected to model to as the basis for their shop drawing creation, and give guidance to the general contractor. Structural engineers for years have had notes in our design drawings that say contractor shall coordinate, contractor shall verify. And there's no reason we as designers should not apply that same to the virtual world and move that process ahead. Because what we're really getting at here for the owners is to create processes where their consultants and their contractors can fix things with mouse and a keyboard instead of a torch and a sledgehammer later. And that, if you had to sum it all up, that's really the purpose of the LOD spec, is to create a common vocabulary where designers can ask appropriately what they want construction team to do, and both sides are working in concert for the service of the owner. And because at the end of the day, it's the owner's money. Matt, if you wouldn't mind, show us the last page as we come to close. And I'll turn it over here after we talk about the next webinar after this one for any final thoughts. And I'm going to wait for the next slide to come up here. There may be a little delay on slide 28.
Should be up.
It is. I see it now, and hope everyone in the audience does. These webinars with BIMForum Global, the goal, they won't be every week, but the goal is to weekly bring a variety of topics that are relevant. Some weeks we'll focus a little more on construction side, some more on design side. Many will be bridging between the two. And additionally, we have owners and vendors that will be presenting topics. From the owner's perspective, what does an owner really want? And that can be quite different from the planning and construction department of a large owner to the facility operations side. On September 7th, this is going to highlight a new and emerged section of the LOD specification that BIMForum Global has worked on. We're going to have Lauren Schmidt with Parallax team and Radu Dikcher with SWA Group, and they are going to be speaking on landscape BIM. We're going to bring in topics related to horizontal BIM, coordinating 3D civil information, subgrade utilities, surface, the interface of the architecture of the building coming out, and then the landscape architecture joining in. And we're going to be hitting a variety of topics, not just land-based landscape architecture, but elevated deck, podium deck construction, plazas outside retail shopping centers where you might be above a few stories of parking structure. And this is an area we feel like also has some interesting complexities with BIM. We talked a little bit about tolerances in our webinar last week, and landscape is one where that's going to really emerge. You're dealing with, in many cases, living elements, and their sizes are going to vary over time. And additionally, the coordination of those can be rather involved. With that, Matt, if you have any final thoughts to share with us, I just want to really thank you for bringing a great presentation to us today.
I mean, thanks for having me. I guess my last bit would just be that, this doesn't have to be overly challenging, both, taking your models to the next level and, the automation part. You try to keep it simple and approachable. Both of them can be, well within your reach. So.
Well, thank you very much. With that, we're at time, and we will follow up. Please reach out and connect to us on LinkedIn, and we'll look forward to visiting more next week. Thank you, Matt. Thank you, Louisa.
Yes. Bye.
Bye.